In this lecture, we're going to be discussing section 9.3, which looks at double angle, half angle, and reduction formulas. So we can actually derive the double angle formulas for sine and cosine, and also tangent using our sum and difference formulas. But let's start by looking at our double angle formula for sine. So recall that sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Now, let's say we let alpha be equal to theta and beta be equal to theta, meaning we're letting them be the same. So then we'll have sine of theta plus theta is equal to sine theta cosine theta plus cosine theta sine theta. If we simplify, this is really sine of 2 theta, which is equal to, so we have sine cosine of the same angle. So this is going to be 2 sine theta cosine theta. And this is going to be your double angle for sine, your double angle identity for sine. We can also use a similar format and come up with our double angle formula for cosine. So we can still say, well, cosine of theta plus theta, that's going to be equal to cosine theta times cosine theta plus sine theta sine theta. And just a recollection that if we have cosine alpha plus beta, that's going to be equal to cosine alpha cosine beta plus sine alpha sine beta. So that's why we're here. So that means we have that cosine of 2 theta equals, so this is your multiplying, so it becomes cosine squared theta plus sine squared theta. Actually, it should be minus. Oops. There we go. Okay. Now with cosine, we can also derive a few more things, because if you remember, the Pythagorean theorem gave us the opportunity to rewrite sine squared theta and cosine squared theta in terms of each other. So we can actually do that. Recall that we have the Pythagorean identity. Right, so if I were to subtract cosine from both sides, I'll have that sine squared theta equals 1 minus cosine squared theta. Or if we subtract sine, we have that cosine squared theta equals 1 minus sine squared theta. So what we can do is we can plug in these two values into our double angle for identity for cosine. So for instance, we'll say cosine of 2 theta, well, that's going to be equal to, if I plug in for cosine, it's going to be equal to 1 minus sine squared theta, and then minus again sine squared theta. So this is really 1 minus sine squared theta minus sine squared theta, which is just 1 minus 2 sine squared theta. So that's another identity for cosine 2 theta. You can also replace the sign. So we can say, well, cosine squared theta equals cosine squared theta minus 1 minus cosine squared theta. So this becomes cosine squared theta minus 1 plus cosine squared theta, and that's because we distribute this negative sign. So we have cosine, actually this should be 2 theta. So cosine 2 theta equals cosine squared theta, but that's 2 of them, minus 1. Okay, so these are our double angle identities for sine. Well, this is cosine, but we just looked at the one for sine. And for cosine, you may ask, well, when do we use any of them? Well, it depends on the question, how we want to simplify, what the question is asking, and so on and so forth. Let's look at some examples. Okay, so here we're given that theta, tan theta is negative 3/4. And we're told that theta is in quadrant 2. And we want to find sine of 2 theta, cosine of 2 theta, and tan of 2 theta. So before we even try to do this, what we're going to do is let's draw a triangle and try to figure out how this should look. So if I were to draw my right triangle, we're in the 3rd quadrant. So if we were to be political, it would look something, 2nd quadrant. It would look something like so. Recall that tan is opposite over adjacent. So let theta be here. So opposite over adjacent. Okay, and if we're in the 2nd quadrant, then we know that our x will be negative. So it'll be -4. Now, we need to figure out what our hypotenuse is. And so we can use our Pythagorean theorem. So we know that 3 squared plus 4 squared equals c squared. So this is 9 plus 16 equals c squared. 25 equals c squared. So that means c equals 5. Okay, so now that we have this information, we can simply plug in. Okay, so sine of 2 theta, if we recall from what we just derived, sine of 2 theta, well, that's going to be 2 sine theta cosine theta. Now, sine theta, if we look at this triangle that we just drew, sine, I'm not sure if you guys already know this, so I'll just write it here. So sine is opposite over a hypotenuse, so it's going to be sine of theta is 3/5. Cosine of theta is going to be negative 4/5. And then we simplify. So this becomes 2 times 3. So you can put this like over 1. So 2 times 3 is 6. And 6 4 is 24. So it's going to be a negative 24 over 25. Okay. And we're just going to be plugging in really into our formula like we've been doing before. Cosine 2 theta. So here we can use any formula, but standard we usually go with 2, the first one, cosine squared theta minus sine squared theta. And so again, we're just going to plug in. So cosine squared theta. So what is cosine? So cosine of theta is going to be -4 divided by 5, and we're squaring that. Sine squared is going to be opposite over hypotenuse, and we're squaring that. So 4 times, so when you square a fraction, you square the numerator and denominator. So 4 times 4 is 16 over 25 minus 9 over, so we have 7 over 25. And that's your answer. Now, as it relates to tan, well, we're not going to derive it in a similar way to how we derived sine and cosine. Let me just put it here. So we won't derive the actual formula, but I'll give it to you all as reference. Once I clear this here. Okay. All right, so the double angle formula for tan. So that's going to be bear with me, guys. I don't know where the slide went. The slide might be after the examples, but we'll see. At any rate, there we go. So our double angle formula for tangent to theta is going to be, and we can always derive it, but in the interest of time, we'll just put what it is. So that's going to be 2 tan theta divided by 1 minus tan squared theta. All right, so that's our formula for tan to theta, or the double angle for formula for tan. So I'll just rewrite it here. So tan to theta equals 2 times tan of whatever theta is divided by 1 minus tan squared theta. So plugging in here, so we know that tan of theta, well, they already gave that to us, really, is -3/4. And we're just going to be plugging that wherever we see theta. So this becomes 2 times -3/4 over 1 minus -3/4 squared. So this becomes -6/4 divided by 1 minus 9/16. Okay. So I'm going to do, so we have 1 minus 9/16. So this will be 16 divided by itself. This would be 7. Very good. So we really have -6/4 divided by 7/16. Keep change, flip. So we should get -24 divided by 7. So just some algebra to get to our solution. But like we said before, once you know your formulas, you should be fine. Okay. Okay, so now here we want to use the double angle formula for cosine to write cosine 6x in terms of cosine 3x. So when we talk about double angle formula, recall that it's cosine or sine or whatever the case is of 2 times theta. So we just have to think about, well, here we have cosine 6x, and we want to write it in terms of 3x. And we're using our double angle formula. So there should be some type of 2 times something there. So if we were to rewrite this, this becomes cosine 6x. We can really write this as cosine of 2 times 3x. So this would be my theta. Always good to know that. This would be your theta. So it's like 2 theta. Now we know the formula here is going to be cosine squared theta minus sine squared theta. So we're just plugging that in. So this is going to be, so again, my theta is 3x. So this is going to be cosine squared, my theta is 3x, minus sine squared, again, 3x. Okay. Alrighty. The question though says to write it in terms of cosine. Now we know that sine squared, so it's very important to know all of these. Sine squared theta is 1 minus cosine squared theta. So I can rewrite this as minus, so this would be 1 minus cosine squared 3x. Okay, and so here this becomes cosine squared 3x minus 1 plus cosine squared 3x. We have 2 of these, so it becomes 2 cosine squared 3x, and then minus 1. This is now in terms of cosine 3x. Okay, so it all depends on what the question is asking, which identity we would use. Okay, so here we're asked to verify the following identity using our double angle formula. Okay, so recall that when we are verifying identity, we start with one side, right? And we try to prove that it's equal to the other side. And you really want to start with the more complicated side. And for us, I think that's sine theta plus cosine theta squared. And so this is sine theta plus cosine theta squared. Okay, so we can, just like a regular binomial, we can FOIL this out. So this will be sine theta plus cosine theta times itself. So if you multiply it times itself, you have sine squared theta plus sine theta cosine theta plus another, so I'm foiling, plus another sine theta cosine theta. And then we have cosine squared theta. So this becomes sine squared theta plus 2 cosine, well, 2 sine theta cosine theta plus cosine squared theta. Now, always, when you see sine squared, cosine squared of the same angle, we should automatically think, oh, this looks familiar, right? Because this is going to be my Pythagorean identity, because we know that sine squared theta plus cosine squared theta, well, this is just 1, so this is going to be plus 2 sine theta cosine theta. Know that 2 sine theta cosine theta, well, that's our identity for sine 2 theta. And so this means we have proven this identity is true. So with proving that an identity is true, we want to make sure that we want to make sure that we and proving that these are true, we want to make sure that they're equal to each other. Okay. Alrighty, so now we're going to look at the reduction formula. And so really, I think this should be the same. Use reduction formula to imply an expression in terms of sine. I think this was an extra slide, but here we are. So this is our reduction formula. So basically, we have sine squared theta equals 1 minus cosine 2 theta divided by 2. Cosine squared theta equals 1 plus cosine 2 theta divided by 2. And tan squared theta equals 1 minus cosine 2 theta divided by 1 plus cosine 2 theta. Now, with these reduction formulas, we can use them to do quite a bit of things, but I'm just going to do a quick example for us. We want to write an equivalent expression for cosine 4 to the 4th power that does not involve any power of sine or cosine greater than 1. And so for this problem, we're going to have to utilize our reduction formula. And so let's just to be clear with the reduction formulas, we rarely use these. So that's why I didn't spend a lot of time deriving these. But it's good to know because, again, it depends on the type of questions you may be given. So if you think about something raised to the 4th power, so we have cosine to the 4th power x, right? So that's going to be equal to, we can rewrite this as cosine squared x, and we raise that to the 2nd power. Now, we know what cosine squared x is equal to based on the reduction formula. So let me just snag this for us. So You can have it on this slide. So cosine squared theta, that's going to be equal to, so I'm just going to plug it in here, 1 plus cosine of 2 theta, well, in this case, our theta is x, divided by 2. And this is being squared. So when we're squaring something, of course, we're multiplying it by itself. So you have 1 plus cosine 2 theta, or 2x, divided by 2 times itself. 1 plus cosine 2x divided by 2. So then this becomes, you FOIL the numerator, of course. So this becomes 1 plus cosine 2x plus cosine 2x. And then we'll have cosine squared 2x over 4. If we simplify, this becomes 1 plus 2 cosine 2x plus cosine squared 2x divided by 4. And we can always pull out this 1/4. This 4 here, we can pull it out as 1/4. So we'll have 1 plus 2 cosine 2x plus cosine squared 2x. Now, of course, we can still rewrite this cosine squared 2x, right? So this becomes 1/4 1 plus 2 cosine 2x plus, so cosine squared 2x, we're using the same formula here. So this would be, actually we can just FOIL the 1/4 individually. Let's do, I think that would make life a little bit easier for us. It would get complicated. So this would be 1/4 times 1, then 1/4 times 2 will give me a half. And then I have cosine 2x. And then this becomes plus 1/4 cosine squared 2x. So now I can rewrite this cosine squared 2x. So cosine squared 2, so in this case it's 2x. So we'll use this reduction formula again. So we'll have here 1/4 plus 1/2. Just write in the first few terms. So this becomes now 1 plus cosine 2 times 2x, because this is my theta, okay, divided by 2. So I can pull this 2 out. So this becomes 1/4 plus 1/2 cosine 2x. So 1/2 plus 1/4 is going to give me 1/8 plus, and this 1/2 is coming from my denominator of 2. This becomes plus cosine 4x, because 2 times 2 is 4. Okay, now the last thing we can do is combine or constants. So this would be 1/4 plus 1/8. 1/4 will become 8 over 4. Actually, no, 2 over 8. So this would be 3/8 plus 1/2 cosine 2x plus cosine for x. So this is how you would utilize your reduction formula. So like I said, with your identities, it all depends on what the question is asking us to do. The last set of formulas we're going to look at are the half angle formulas. And so again, in the interest of time, we won't go into deriving these. So we have that sine of alpha divided by 2 is equal to plus or minus. So what we need to always note is for your half angle formulas, there is a possibility that you'll have the negative or the positive of the solution. So we'll have to look at the quadrants to determine which solution we're going to take, whether it's going to be a negative or positive. Very important to note, tan has 3 different identities for its half angle. So again, it all depends on what the question is asking or how it's worded. Okay, so let's look at some examples that we would use for your half angle formula. Now, let's say we're given that tan of alpha is equal to 8 divided by 15, and alpha lies in quadrant 3. So again, I'll draw my triangle. So alpha lies in quadrant 3. No, this is not the correct triangle. So we're coming from the center. There we go. Here's my right angle. Okay, alpha lies in quadrant 3. Okay, so that means that both x and y are negative. So this would be tan is going to be, this is going to be my opposite. So let's say theta is here. Opposite over adjacent. Well, we know that these are both going to be negative. Now, at any rate, we will still need to find our hypotenuse before we even dive into this question. So using the Pythagorean theorem again, we know that 15 squared plus 8 squared, you can put negative if you want to, equals c squared. And if you solve this, you'll get that c equals 17. All right, so we have all of those information. So if we're trying to find sine of alpha over 2, now based on my double identity, sine alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha. I'm just writing in the formula here. These look quite the same. Okay, so we have plus or minus the square root of what is cosine of alpha? Well, put alpha instead of theta. Okay, so 1 minus, so my cosine is going to be negative 15 divided by 17. That's going to be my cosine, and this is all over 2. And this is all under the radical. Okay, now doing some simplification. I'm going to leave this to your imagination. But I'm just going to do this part. You should have for your numerator 32 divided by 17 all over 2. And once you simplify, you should get at least plus or minus 4, plus or minus, well, let me write this part first then. 16 divided by 17. We know that if you're taking the square root of a fraction, you can take the square root of the numerator and the denominator separately. So this is really plus or minus 4 over root 17. Okay. If you rationalize, well, this becomes, let me put it on this side since I need the middle. This is going to become, meaning you're going to multiply by root 17 over root 17. So this is going to become what? 4 root 17 divided by 17. Okay, and that's going to be my answer. So with these problems, you definitely want to simplify as much as possible and go as far as possible. And we'll be doing the same thing for cosine. So this is going to be equal to plus or minus the square root of, and just to make note, remember we have two possibilities, plus or minus. But since we're in the third quadrant, all students take calculus. Okay. All students take calculus. So this was going to be plus or minus 4 over root 17. So it was negative 15. This became a positive. Okay. All right, so since this terminal side here, this is our terminal side, negative 15. Since the terminal side is still kind of in the second quadrant, and sine is positive in the second quadrant, then we take the second, the positive value here because of our terminal side being in the second quadrant. Okay, all right, so in the second portion, B, we're going to plug in similarly the formula. So this is going to be the square root of 1 plus cosine alpha divided by 2. And so, of course, we're just plugging in. So cosine alpha is going to be negative 15 divided by 17. Wait a minute. Oh, yes. Divided by 2, all under the square root. Okay. And this is going to be, once you simplify, just the way we did the previous one, you should get negative root 17 divided by 17. Okay. And we're taking the negative side of this because we're talking about opposite over adjacent over hypotenuse. All students. But we're still rallying back also on the fact that the terminal side of this triangle is also in the second quadrant, and that's what we used in this And we know that cosine is negative, right, in the second quadrant. Yes, all students. Only sine is positive there. In a similar fashion, we would go to tan. So we know that tan of alpha over 2, that's going to be equal to plus or minus the square root of 1 minus cosine alpha divided by 1 plus cosine alpha. And of course, you're just plugging in and simplifying. So this becomes plus or minus. So you'll have 1 minus negative 15 divided by 17 divided by 1 plus negative 15 divided by 17. Okay, so if you simplify, I'm going to say practice here. I'm going to say practice here as well. Hopefully you guys do practice these. Okay, if you simplify, you should get negative 4. And we're again, since tangent involves your adjacent, which is in quadrant 2, right? And your tan is actually negative in quadrant 2. We're going to have a negative solution here. Okay, sine is the only thing that's positive in quadrant 2. Okay, well, that's it for today. We'll stop here. Be sure to do your homework. Alrighty, have a great day, guys.